Hi, my name is Clara, and today I'm going to talk to you about casual numbers in computers. So, the first question I'm going to ask you is, how do I get a casual number from a computer? Well, I can't. Why is that? Because a computer follows a deterministic process, which means you give it input, you give it a command to follow, so you give it some instructions, and it gives you an output. It's a very linear process, and it's just a step-by-step situation. And how do you get casuality? Well, casuality is not predictable, which means you just throw dice or just pick a random card from a deck. So, how can we generate casuality from a computer? Again, we really can't, but we can get pretty close. How do we do that? With pseudo-casual numbers. A pseudo-casual number is a number that can substand a quantity of statistic tests that will determine its casuality. So, how do we get them from a function, for example, in computing? Well, you will probably use the function rand, which comes from a pseudo-random numbers generator. What is that? Well, a pseudo-random numbers generator is simply an algorithm that will generate a sequence of numbers. This sequence has a length before repeating itself. So this length is called the period of the sequence, and the longer the period, the better the algorithm. How do we start the algorithm though? Well, the key to an algorithm is called the seed, which is the starting number. How do you get a seed? You could get it in a very aleatory way, so just tell the computer, take the time of the day that it is and use it as a seed. But remember, every time you use the same seed, you're going to obtain the same sequence. So somebody, a couple of years ago, invented another algorithm that is sort of a potentiated way to make sure that your sequence of numbers can substand all of the statistic tests. This is the linear congregational generator. The LCG works based on a formula that I can put right here. So in this formula, xn is the seed, so it's the first number that our LCG is going to get. And the second thing we need to know that xn is the n-ism, which means the n times number that the casual generator is going to output. Then we need to know that a, c, and m, which are constant values, have some rules between each other. So, rule number 1, c and m need to be prime numbers between each other. Rule number 2, a minus 1 has to be divisible by all the prime factors of m. And rule number 3, if m is divisible by 4, then a minus 1 needs to be divisible by 4. Pretty simple, right? So let's see how it works. So, we just follow all of the instructions. But you might wonder, what is that sign that is like the percent sign? Why do we have a percent sign? Well, the percent sign is called the mode function. The mode function gives you the remainder of a division. So whatever you take, you mode it, which means you put this sign here, you're going to get an output. This output is going to be the remainder of your division. Alright, let's take a look at an example. So, the syntax for an LCG algorithm is A, C, M, and then it's followed by the seed. So, I've written this sequence. Let's verify if it's okay to use as an LCG algorithm. So, as you may remember, we have 3 rules. C and M need to be prime between each other. In this example, they are: A minus 1 needs to be divisible by all the prime factors of M, and in this case, it is. And then, a minus 1 needs to be divisible by 4 if n is divisible by 4, which again, it is. So, moving on. x1 is going to be equal to 1, which is our seed. And then for x2, we're going to have to execute the formula. So, a times x1 plus c modulo m equals 5 times x1, which is 5, plus 1, which equals 6, modulo of 16 gives as a result 6. Why is that? Because 6 divided by 16 equals 0 with a remainder of 6. So moving on, we'll just do the same thing for the next number. So x3, 5x2 plus 1 modulo 16 equals 15. And so on and so forth. So as you can see in the wheel, we will get all the numbers in the sequence. So 1, 6, 15, 12, 13, and as you go on, you will have all of the numbers between 1 and 16. So you can obtain all the numbers between m and the seed. In coding, one might translate this to a for loop. What is a for loop? You can see for I equals 0, so I is just a random variable, equals to 0, to the second part, which is going to be our condition, and then we get an I++, which means make it iterate again. It's going to iterate over this formula n times to get n numbers, and then it's going to repeat itself again. If you remember earlier, we talked about these statistic tests. So how do we test these numbers? Well, we have two main criteria, the Turing criteria and the von Neumann criteria. The first one says that apparently all of these extractions need to be indistinguishable from ones generated by a mechanical casualty. So for example, if I want to get a casual number between 1 and 12, the algorithm results should be apparently indistinguishable from the mechanic ones. So I should get 2 dice and try it over and over until my sequence is very similar to the actual casual one. The second one, which is the criteria of von Neumann, says that the distribution of numbers generated needs to be equal. So you need to be able to see them in a graph. You can verify these criteria with a frequency histogram. So in this histogram right here, we've got a value between 0 and 1. Variability interval m equals 50. We have smaller intervals that are all obviously equal, they're all the same. And the number of values that fall in every interval, so with every generation, is equal to 10,000. So we can just use the equation that says that the theoretical value, which is the optimal value, equals the number of tries, so in our case 10,000, frac the number of intervals, which is 50, which gives us 200 as a result. So we put all of our values in an histogram, just like this one, and we can see which values actually fall in that category. The last statistic characteristic that we can see is the correlation. So what is correlation? Correlation is a characteristic that two numbers might have if they're in some way related to each other. A good algorithm has no correlation. So this would be a very bad algorithm because we can see clear lines, and this would be a very good one because it looks like there is absolutely no correlation whatsoever. So now that we've explored casual numbers, you might think that all numbers are just given like this, casually. Phone numbers or IP addresses or whatever, but it's not really like that. Because some numbers actually have some theorems behind them. And I wanted to talk to you guys about one of these theorems. Today we're going to be exploring the algorithm behind credit card numbers. So it's called the Lund algorithm because it was invented by Hans Peter Lund of IBM. According to this algorithm, you can determine if a credit card number is valid or not. So, number 1, you need to multiply every other digit by 2, but starting with the number's second to last digits. Second step, you need to add the sum to the sum of the digits that weren't multiplied. In the end, if the total last digit is 0, number is valid. So, it's kind of confusing. So let's actually try it on a number. So you see this number right here, it looks like a very random credit card number. So let's underline every other digit, starting with the number from the left. We'll multiply all of those, and as a result, we get the number 13. So now let's add 13 to the sum of the other digits, and we get 20. So the last digit in the sum is 0, and the modulo is 0, so this credit card number is valid. But that's not all you need to know though, because American Express uses 15-digit number, MasterCard uses 16-digit numbers, and Visa uses both 13 and 16-digit numbers. So now you might ask yourself, how do we separate the MasterCard 16 digits and the Visa 16 digits? Well, this is very simple. Because American Express, for example, starts with the number 34 or 37. MasterCard numbers start with 51, 52, 53, 54, 55, etc. And most Visa numbers start with the number 4. So, next time that you think about paying something with PayPal, know that the algorithm that they're using to figure out what credit card it is and if it's valid is this one. I hope you enjoyed the video and you learned something new.